Greetings and welcome to our 63rd test and measurement video. Today we'll look at taking automatic measurements in the time domain using the Tektronix MDO3104 oscilloscope. First, we'll need a signal to measure. A Tektronix MDO3000 series oscilloscope has an available internal arbitrary function generator, so we'll start with that. The output on the back panel is labeled AFG out, and it can be very easily connected by means of a BNC cable to the channel 1 analog input on the front panel. When the AFG button on the front panel is pressed, the default sine wave is activated. Since by default channel 1 goes active when the oscilloscope is turned on, the signal is immediately displayed. The sine wave parameters are initially set by default, and they may be viewed in the oscilloscope display since AFG is on. Press Waveform to see the types of waveforms that are in the AFG library. Then press Waveform Settings to view some parameters: frequency, period, amplitude, offset, and high level, low level, which refer to the positive and negative going peaks of the waveform. Output Settings opens another menu on the side of the display. Load impedance can be set high Z or 50 ohms. Up to 100% noise can be added to the signal that is displayed. Here's what 15% looks like. You can see that triggering is just now being lost. The auxiliary output can be main trigger, event, or AFG. High and low level can be set. Presets can be determined by the user or made to conform to transistor, or complementary metal oxide semiconductor logic. Now that we have a sine wave displayed in the time domain, we're ready to demonstrate the procedure for taking automatic measurements. First, press Measure. The button located in the upper left corner of the Wave Inspector section is Measure. The Measure menu appears across the bottom of the display. Press the soft key associated with Add Measurement. The relevant menu comes up to the right of the display. To begin, check to see if the top menu item, the source, is set at channel 1. If not, use multipurpose knob A to make the adjustment. Phase, if it is to be other than 0 degrees, requires 2 sources. The second menu item is Measurement Type. The choices are Snapshot All, Frequency, Period, Rise Time, Fall Time, Delay, Phase, Positive Pulse Width, Negative Pulse Width, Positive Duty Cycle, and Negative Duty Cycle. To view these measurements, simply select them using multipurpose knob B, and then press the soft key associated with OK Add. Let's go back and choose the square wave. Now we'll scroll B down to frequency. Notice that a very interesting window comes up that shows a relevant formula, a generic image of the waveform, and a descriptive statement. For this parameter, it is noted that frequency is the reciprocal of period, and we are reminded that frequency is inversely related to time. Similarly, we can scroll through the parameters, and relevant information for each type of waveform is displayed. Returning to frequency, we'll press OK, Add Measurement. In fact, we'll press it 3 times to show how it works. To see the results, it is necessary to press Menu Off. And there are the multiple measurements. In this instance, they're all identical. Each measurement has the value 100 kilohertz as set in the AFG, plus mean, minimum, maximum, and a very slight standard deviation. These are the automatic measurements. The settings survive in non-volatile memory when the instrument is powered down. However, the actual measurements, as opposed to the settings, are made in real time. There are some additional menu items that pertain to automatic settings. Indicators place lines on the display highlighting the portion of the waveform that is being measured. For example, in frequency, the first complete cycle, including positive and negative going parts, is indicated. DMV can likewise be turned on or off. It generates a digital multimeter type readout above the display with large clear characters showing, in this instance, voltage or frequency. Frequency is shown clearly as 100 kilohertz. Waveform histograms may be set to show vertical or horizontal histograms, which are time-correlated graphs depicting the waveform metrics. The display can be made linear or logarithmic. Gating determines whether the metrics will be full screen or constrained between cursors. Statistics likewise can be turned on or off, regulating whether the metrics are displayed for each measurement that has been added. Thanks for watching. New videos are added periodically, so check back frequently.